Friends, welcome to my YouTube channel. Dhanesh here. In this video, I am going to discuss about t-test. In the last video, we were discussing about z-test. Let's continue. This is a quote from Sir Isaac Newton. If I have seen further than others, it's by standing upon the shoulders of giants. Let's continue with t-test. Before getting into t-test, I am giving some idea about bivariant analysis. This is part of exploratory data analysis. You may be familiar with exploratory data analysis. Exploratory data analysis is classified into three. That is monovariant analysis, bivariant analysis, and multivariant analysis. See, bivariant analysis means there should be two variables. So the variables can be numerical or categorical. When both the variables are numerical, we will go for correlation coefficient. If both are categorical, we will go for chi-square test. If one is numerical and another one is categorical, we will go for t-test, z-test, and ANOVA. So this is a very nice table. So you can understand we will go for t-test when one variable is numerical and another one is categorical. Fine. See, a t-test, what exactly is a t-test? A t-test is a type of statistic used to determine if there is a significant difference between the means of two groups. See, when there is a normal distribution, normal distribution or Gaussian distribution or bell curve. So this is the first bell curve and this is the second bell curve. This is the mean of the first bell curve and this is the mean of the second bell curve. So the difference between the means means this is the difference between the means of the two normal distributions or two Gaussian distributions or two bell curves. So you understood. So t-test was developed by William Seeley Gosset 100 years ago to determine the difference between Bali from different fields. He called it as students t-test and this person only developed, this is the scientist who developed t-test, William Seeley Gosset. Okay, fine, let's continue with another important fact you need to understand is the t-score. So the t-score is a ratio between the difference between two groups and difference within the groups. Very important. T-score is the difference between two groups, means the difference between the mean of the two groups. This is the first normal distribution. Just 1 second. Yeah, this is. So this is the first normal distribution and this is the second one. So the t-score is the ratio between the difference between these two groups and the difference within the groups. So a large t-score tells you that, see, I will give you the mathematical formula for this in the next step. I will be giving in the next slide. You can see that. So this is the definition for t-score. It is the difference between two groups, ratio of difference between two groups to the difference within the groups. A large t-score tells you that the groups are different. A small t-score tells you that the groups are similar. So this is the mathematical formula for the t-test score. We can, that difference between two groups, we call it as the signal, and the difference within the groups, we call it as the noise. That is difference between group means and the variability. Noise means variance. See, noise, we will write it in terms of the variance of two groups. So the difference between the means x1 bar minus x2 bar, the modulus of x1 bar minus x2 bar, that is the signal, divided by root of S1 square by N1 plus S2 square by N2. What is S1? S1 is the variance. See, we have separate videos for variance, covariance, Pearson's correlation coefficient. Everything is there. Please watch those videos. So in the playlist statistics. So Sn square is the variance and S2 is the variance of the first group, S1. is the variance of the first group, first one. S2 is the variance of the second group. N1 is the number of samples in the first group. N2 is the a number of samples in the second group. You understood? So you understood. S1 is the variance of the first group, S2 is the variance of the second group. Fine. So this is the mathematical formula. See, if you are considering for independent groups, there is a this formula you can use it for the t-score. T-test for independent groups, it is sigma 1 square by n1 plus sigma 2 square by n2. N1 again the number of samples in the first group, n2 again number of samples in the second group. A sigma 1 is the standard deviation of the first group. Sigma 2 is the standard deviation for the second group. That is, for independent groups means that the groups they are not interrelated. There is no correlation between the two groups. This is test for dependent groups. T-test, the equation. See, here you will get this factor R. R is the correlation because they are dependent. Then at that time the formula is root of sigma 1 square plus sigma 2 square minus 2R. Sigma 1, sigma 2, again sigma 1, the standard deviation. Sigma 1 is the standard deviation of the first group and sigma 2 is the standard deviation of the second group. R is the correlation between the groups. That is the t-test for the dependent groups. Fine. See, this is, I am giving the degree of freedom, another important aspect related to all these tests. There is a separate video for degree of freedom in the playlist statistics. You can watch it. So the degree of freedom for one sample t-test, it is n minus 1. Two sample t-test, it is n minus 2. Even when we discussed about chi-square test and all, we have discussed the degree of freedom in the separate video. We discussed all these aspects. See, for the degree of freedom for one sample t-test, it is n minus 1, and two sample t-test, it is n minus 2. You have for chi-square test, it is a contingency table. It is r minus 1 into c minus 1. That's the degree of freedom. Fine. So you understood that as well. So this is all about t-test. Thanks for watching. Please like, share and subscribe. Thanks a lot.